My name is Ram. I'm a senior associate at PwC, and I've been working in Salesforce and Force.com ecosystem for last 4+ years. I have strong experience in Sales Cloud, Service Cloud, Force.com, analytics, and integrations. For last couple of years, I've been heavily focusing in front-end development in JavaScript and HTML, and that's how I came to this talk. And today we are going to talk about a visualization library called D3.js. So it's sort of kind of aligns with the theme of the Dreamforce, like it's more around the analytics product, which is Wave. So we are going to talk along that lines, but it's an open source library, so you guys can, after this talk, once you get the basic stuff, you can try to work on your own. And before I begin this talk, when it comes to doing visualization and charting in Visualforce, Salesforce ecosystem, there are a couple of options. The first one is the Visualforce charting, which is the default option, and the other options are JavaScript-based libraries like Google Charts or iCharts. These libraries are pretty good, and they do work very well, and they provide the APIs. You pass the data, they process the data, so that's the contract. The only problem is like you can only do certain things with these libraries, and when you go beyond what they're trying to provide, and if you want to implement something unique, which is like you want to implement your own visualization, and that's where you find the limit. And these libraries are written for automation, not for you to tinker with it and improve your creativity. So that's where D3.js fits into the picture, and that's the goal of the talk today. And also we are going to integrate with Salesforce.com Analytics API. So that's another cool thing. So we are going to bring live data from Salesforce, and then we are going to create some nice charts, and then I will show the demos as necessary as we move along this talk, and we'll have some time for Q&A as well. So D3.js is a data-driven document. That's the definition. So the idea here is like you have some data and you want to do some projection using JavaScript libraries or any in this case, and then the way to do it in the browser is only to create some kind of a DOM. It's going to be based on, since browser is based on DOM, any operation we do in the browser is a DOM operation. So that's kind of the name here, data-driven document. And I personally like to refer D3 as a data triggering DOM updates. So that's what most of the things we do in this when we are working in chartings. It is web standard. It is based on web standard, and we use all the good technologies we already know, which is HTML, CSS, and JavaScript and SVG. So there is some of you might be new to SVG, but it's we kind of only touch the basic concepts in SVG, and D3 does behind the scenes the SVG manipulation and SVG object creation for us. So we don't touch it very deep. And as I mentioned, DOM is the container, and anything you do in the DOM is kind of, you can easily debug with your traditional tools like Firebug or Chrome development tools. So that's kind of nice and handy, and it's a transparent representation. You see what you code, and there is no intermediate layer, so your mental model is well aligned with what you see in the browser. And D3 is kind of divided into multiple modules, which is core, scale, layouts, and SVG and geometry. We will briefly cover some of this stuff since it's an introduction level talk. We don't go into deep into any one of these things, but I do explain some of these things as we move along. And the best part of the D3 is it's open source, so that's a cool thing. So I just mentioned D3 is about web standard, and how do we go about creating these libraries? How do we go about creating these charts in D3? So these are some of the steps, and you find the steps again and again in most of the chartings as we go along. The first step is loading the data, and it's kind of, in our case, it's going to be the Salesforce Analytics API. And you can even load data from your remote services, and D3 provides XHR style AJAX request for us, and you can even read your input data using JavaScript, which is in a proprietary format using JavaScript function as a scale. And the next step is to select and bind. The select and bind is basically, once we got the data, we are just going to push the data to the DOM and do some charting on it. And then the next step is enter and append. This might be a little bit strange to some of you, but as I go through the chart and walk through the examples, it will make more clear. The enter and append is kind of, you got some data from server and you're trying to update the DOM, and the enter selection tells you like what element in your current data set as corresponding element in your DOM. If it does not have any corresponding element for the current data element in the scope, it creates a reference called node, and then later on you append the actual element during the data append process. And then you do transform and translate. Transform and translate is nothing but you have your business data. It's like, for example, it could be revenue data or it could be any categorical data. These data needs to be smoothened before you present it in the browser, because the browser has a very limited real estate. We need to transform this data into a two-dimensional coordinate system data. So that's where the transform and translate come into picture. And then we have something called transition. That's like all the similar to what the other frameworks does. You just do some animation. And exit is a special operation, and I'll walk through this as we move along. It kind of helps us to emulate the sort of join-like scenarios in the UI. So I mentioned about the D3 selections. These are some of the selections available in D3, and folks who are coming from jQuery background is kind of find it very familiar. And D3 selectors works similar to jQuery select, and it supports all the predicates. And you can select an element by different properties like a CSS class or a element ID or even a partial element ID. So, and one more thing D3 does is like each one of, if you have an array of data and you are trying to create, for example, append it to a list of elements in the DOM, D3 stores all this value in a special property called __ data. This is the attribute we later on use for doing any calculations. So this is a little bit low level, but I would like to just underscore it so you guys get it. And D3 provides two types of selectors, which is select and select all. And as the name tells, select matches only the first, and select all matches all the elements in the DOM. And you can, combining these two selectors, you can kind of emulate an hierarchical and nested selections. So, which is very powerful later on. And these are some of the example selections I have on the right hand side of the screen. These are some of the basic SVG shapes. We will use some of them in this presentation, but we don't actually create these elements. D3 does it for us, so we just only understand what are the attributes needed to create one of this element, and then we just populate these attributes, and D3 does the magic for us behind the scenes. So that's enough of talk. Let's try to build a simple example, which is building 4 circles. And that's on the left-hand side, we have the simple syntax for the circle, which is the SVG equivalent, which needs an x and y value. The x and y value is basically a point in the two-dimensional coordinate system, and you have the radius, which is the r. So these are at least 3 attributes, but we do some more things like coloring and stuff like that. The first step in the code is like I'm defining a color scale. We look at scale in deep in few minutes, but for now assume it's a function. It takes a value and returns you like between it picks one of the value in the 10 colors and returns one of the 10 colors. That's the idea of this function. As I mentioned in the previous slide about load and bind. In this scenario, we are not loading any data from the server. I'm just assuming the data is static, but we are trying to bind the data to the server. Since all the visualization or charting we are doing in D3 is SVG based, the first step in the process is to create the SVG element. That's what I'm doing here. In this line, I'm saying D3.select chart ID and append SVG, and I'm setting the property for the SVG canvas, which is the width and the height. And then in the second step, I'm telling like see if you have already have created any circles. If so, just bind this data. And we are going to identify these circles by a index function, which is the function I have here. It's basically the radius of the circle. We are assuming for this context the circles are unique, there's no duplicates. The second step is, as I mentioned, as we saw on the earlier slide, enter and append. In this case, if we are not going to have any circles because we are executing this for first time, and the enter selection is going to give the references for the empty slots. That's how D3 internally works. In case we do have some circles, it will update the existing ones and only give the references for the null ones. And then when we call append, that's the step we actually create the circle. That's a step we actually create the circle. And then we do some transform. The transform here is it's very simple. For this context, I'm setting the y value to be static, which is 250, and I'm setting the x value, which is a JavaScript function. I'm multiplying it by the index value plus 3 times d, and I'm adding some constant of 50. And also, I want some animation. I want to zoom out from 0 to the radius size. So that's what I'm doing in the next few lines. And I'm also setting the color of the circle, which is I'm going to dynamically get it from the color function I defined in the step 1. And I'm just setting the circle stroke, which is the thickness of the circle, as 4. And that's this one. Let's look at the demo. So this is our first demo. And so basically, we just created a bunch of circles. And if we look at, as I meant, the power of HTML, if we want to inspect what's going on behind the scenes, we can easily inspect the code, the circles we created, and the attributes. And it's kind of very easy to debug. And since it's all browser-based, if you're writing in like Swing or in Flash, it's going to be very hard because you program in one language and you see the result in a different place. That's something important to remember. I mentioned that D3 is data joins, and data joins is kind of like analogous to the SQL sort of joins. It's not technically SQL, but we do emulate certain things here. So if we are trying to do an interactive visualization, that means like we have some data for some period of time in the UI, and this data is going to be removed after certain period of time, and then the new data is going to come to the UI. So if you think about implementing this scenario is basically your typical data join scenarios. So that's what I'm showing the screen. For this example, like we have first time we have a circle which is 1 to 5. We are creating a circle of 1 to 5. And then I'm trying to update this circle with some values later on sometime. Like I'm keeping the odd numbers. I'm adding one more odd numbers, which is 7. And then when we do this update, we don't want the old elements to exist in the UI. So we want to remove them. So because it's no longer part of the current scope of the data. So that's what it is. And 2 and 4 are the elements which exist in the UI, but it does not have any corresponding element in the scope. So we want them to be removed. That's the exit syntax which we saw a while before. So this is how the exit function helps us to emulate whether we want an intersection or a union all in this context. Let's look at the update demo. So what I'm doing is I'm creating some random numbers, and then I'm just keep update calling that circle draw function. This function is basically going to find does these elements have any corresponding the data elements have any corresponding DOM element. If there is a match, it will keep that element in the current transition. If they are not part of the current scope, those elements get removed. So that's what you see in the UI, like the circles coming and going. Thinking in D3, this is one of the fundamental concepts. I want those folks who are curious to try D3 to get it. D3, working in D3 is similar to the geometry some of you guys did in the high school. So you just draw two x and y axis, and you plot some point, and you connect those points for a simple line chart. So that's what we are going to do here, except we are going to do it a little bit programmatically. And D3 provides the tool set to do that, but still we have to do the painting and connecting these dots. So that's what this graph is about. And the one of the nuances I want the folks in the audience to understand is the 0, origin in the traditional algebra starts in the bottom left corner of your graph, but in the HTML CSS terms it starts only on the top left corner. So this is something to remember, because when we apply any scale function to transform the y values, we need to understand that this is how the browser works and this is how we need to transform. So that's something to understand. And I also mentioned two functions here, y scale and x scale. These scales are the transformation function, which I kind of mentioned before. So the reason for a transformation function is like when you are bringing the data from your server or any other external data sources, these data sources are going to be data of different domains, and these data needs to be normalized in a fashion which we can represent these data as x and y coordinate points in the two-dimensional system. So that is a fundamental thing we are doing throughout D3 charting. So that's why like I have a y scale function which maps any y value, which is in this case a to z, to a pixel value in the y-axis, and I have a x function which takes the x value, which is 0 to million, into a x coordinate point in the two-dimensional coordinate system. So this is a simple code for bar chart, and here like we have some data, and as I mentioned, I'm defining two scales here. One is range round band. It's an ordinal scale, and ordinal value is the string values like your categories, pick list values, etc. These values are ordinal values, and the linear values are your numeric values. So I'm defining two scales for this, for taking these two data points and to translate them into an coordinate system points. That's why I have two scales. And as usual, I'm trying to select the chart, appending the SVG and SVG width and height properties. In this case, I want to do a bar chart. So in bar chart, syntax for D3 is on the left-hand side, which is rectangle. We need to populate x value, y value, width, and height. So that's all I'm setting up here. And for x value, since we need to apply the transformation, I'm calling the x scale function here. So that's our quarter. In this case, it's Q1 2004. And for I'm setting the width here. And for y values, we are applying the y function, which is a linear function, which is going to take our values like this and transform them into y coordinate point. As I mentioned about the 0 nuance, to handle that, I kind of flipped the scale here from height to 0 instead of 0 to height. This is the way you kind of come over that nuances with the browser. And also like when I set the height, I'm trying to return the height as the total height minus the y scale function value. So so that the graph starts from the bottom and just works upwards. Otherwise, it will look inconsistent. Let's look at the demo for this one. So this is our bar chart, and if we want to check what we did, so we just created a kind of a rectangle syntax, and we populate some of the properties for the rectangle. So that's what we did here. All right. Moving on. For some of the advanced JavaScript users, like you might think like it's what I did is kind of a DOM manipulation, and you might be wondering like why should I even use D3 for these things? I can come up with my own framework, or I'm fine with whatever I'm doing. I can just do this myself. The problem is like thinking in data is very important. It's not about you just we are used to the idea of manipulating the DOM, but when it comes to visualization and charting, you start with data. So the only framework which does that is D3, and that's a big difference. And some of the things I will show the demos, but we may not talk here, like layouts and complex scales and axes. These are things not easy to roll out, and if you try to roll out by yourself, you are definitely going to end up with a lot of code, and you will regret with that for some time later on. So there is a good reason to use D3. And the most important thing is, like, D3 is kind of like, it is a JavaScript, but it still kind of abstracts the underlying complexity and allows you to think in terms of that abstraction, which is very important for productivity in any field. So D3 does that for us. For example, the SVG path generation is kind of very weird if you try to look at it. So those are the nuances you need to understand when you're making this kind of choices. Salesforce Analytics API. It is introduced in Winter 14, and it is going to be the data source for our application, and I'll show it in a few minutes. And the Analytics API is kind of very cool, because like if you have some reporting data in Salesforce, there's no way for you to get the data outside the Salesforce ecosystem. You can do with Excel, you can do with email, dashboard refresh, but these are not it's okay for the business users. For programmers, it's not going to be anywhere close what we want. So if you want to do some visualization, or we want to do some integration of this data, this is the only option you can do. And more intuitively, if you think about report, what you are doing in a report is kind of group by and some complex aggregations. These are the things you can try to automate with a report. And on the front end, for example, for our purposes, we can just simply consume this data and do some presentation, which is kind of really cool, and you can even avoid some coding, complex coding, if you think about it clearly. And these reports can be run synchronously or asynchronously. The report API kind of supports the similar kind of filter query, which the reporting engine supports. So, which is kind of very nice. So this is how you access the Salesforce analytics report. So we use a client-side library called ForceDK, and I assume some of you might be aware of it or used it. So ForceDK is a JavaScript client library to access Salesforce resource from JavaScript perspective. It's very cool. You can even execute SOQL query from this, and also access any REST API in Salesforce ecosystem. So that's what I'm doing here. It's very simple. It's similar to any jQuery like accept or request. You have a success function. You have a function on success, and you have a function to handle error. So you just do some processing based on that. This is the structure of the response we get from Salesforce, and I'll show it in the demo so that it looks very cool. Let's go here. I'm not sure how many of in the audience tried to read the spec for the analytics report. If you tried it, it might look confusing. One of the testimony for this talk is that trying to understand information in an easiest possible way. So to prove that, I just took the Salesforce Analytics API response. I created a tree chart, so you can just nicely explore what information available in the response here. So this is the same response we see in the report actually. So if you try to read the spec, I'm pretty sure it's kind of a little bit confusing for the first time unless you debug the response in the developer console like Firebug or DevTools. So the way you parse this data is like Salesforce provides, the Analytics API provides you the data plus the metadata for the report. So when I explore the extended metadata and look at the detailed column level info, so these are the columns I have in my report, and it kind of tells what is the type of these columns. So using this column metadata level information, we can kind of parse the data we got from the fact map. So then we can build something like, we can do some client-side processing using this information. So that's what I'm doing for this charting. All right. Let me show you the actual report. If you're wondering what is the report we are using for this demo, this is the report. So it's basically an simple opportunity summary report. I just have a couple of columns here, and then this is the report we are trying to consume here. So that is Analytics API, and I do have a couple of demos. This one is conversion analysis. So the idea of this chart is basically, I'm sure most of you guys are aware of the way the conversion works in a sales process. So that's what I'm trying to plot here, and this is like one of the nice kind of charting you can do with D3, because when you try to do stuff like this, the out-of-the-box libraries are not going to do things like this. Your y-axis is the way the conversion process works. So you have lead, you have account, you have contact, and you have opportunity, and you have cases. So this is how like the way the sales cycle works, and the x-axis is the timeline when you created this, when you close this, stuff like that. So without doing any analysis, if we just try to plot this information on a graph, we can simply see the behavior, like when you created a lead, when this lead became converted into an account, how long it took, when you closed the first opportunity, and when you had a first problem, and things like that, and how many events it took to convert this lead into an opportunity. Those are the things, kind of the exploratory stuff you can easily do once you're more familiar with the charting part of with D3. So that's one thing I want to show. The other one is the line chart. It's kind of it's very simple, similar to the bar chart, except I'm doing this projection as a line graph. The y-axis is the months, and the x-axis is the revenue total. And as I mentioned, that D3 path generation is kind of complicated. I want to show it. So this is the sort of path generation which D3 does for us behind the scenes. But internally, we don't do that. We just think in terms of x and y value, and in terms of coordinate system, and translate functions and transformation functions. So that's something to notice. Okay, those are the demos I want to cover, and this is my summary. Consider D3 for when you're trying to create something unique. It's not when you are trying to think in terms of bar chart, pie chart, line chart. It may not make that much sense in terms of value proposition, but if you go beyond that thinking, and you're trying to do something creative, definitely this is the place. This is the library which does it for us, and. Couple of things to notice: it does have some strong learning curve, because you need to be good and proficient in JavaScript to an extent. You need to understand SVG, you need to understand DOM, and there are other options, like I mentioned, Visualforce, charting, Google Charts, and iCharts. These are nice libraries. If you have time in your project, you can try D3, and if you have a time constraint, definitely use some of these options as well. I think these are my references. I will post the material to the chatter feed, and the code will be out by tomorrow. I just need to do some review. Thanks for coming. I hope you find this presentation useful and informative, and you take some of these nuggets of information in your when you go back to implement any charting or analytics work in your day-to-day projects. Thank you. I'll take any questions.
Excellent. Thank you, Ram. So yeah, if you have any question for Ram, please raise your hand and I'll give you the mic.
Okay, I think everybody understood everything. Cool.
All right, Ram. It's very clear.
Okay, cool.
Right.
Thank you.
Thank you, Ram.